Okay, let's do this. This is the end of season 2 of Phase Space Invaders. We've just had 8 great conversations with researchers working on exciting topics. We've had Michele Vendruscolo, who works on addressing protein misfolding through drug design. We've had Ariana Nunes Alves, who tries to study the role of kinetics in drug design, as well as the effects of molecular crowding. We've had Justin Lenkuhl, who develops polarizable force fields for nucleic acids. We've had Vlad Kozhakaru, who investigates pioneering transcription factors involved in reorganization of the genome. Then we've done a conversation with Daniel Zuckerman, whose main focus is on the fundamental statistical mechanics through the lens of trajectory ensembles. We've had Saima Khalid, who studies the bacterial envelope and the physics of permeation of drugs through the bacterial external defenses. We've talked to Paulo Souza, who works on the development of the general-purpose coarse-grained force field Martini. And last but not least, we've had Janusz Bujnicki, who talked about developing methods for the structural modeling of RNA from data and physics. These were the scientific topics, but in every conversation I also try to touch upon social or tangent topics that are relevant to what we do outside of our main research lines, but play into who we are as computational scientists. And so one topic that was kind of recurrent was that of the responsibilities of a scientist. This idea being that we have plenty of people who are intrinsically driven. As research scientists, we really get to, follow our own curiosity. But then, as for example pointed out by Michele, we need to remember that we are appointed by the public on the mission not to just selfishly follow our own personal goals, which we anyway get to do, but also to unlock the understanding of the world for everyone out there, and hopefully to contribute to new therapies, technologies, and so on. So we need to carefully approach and balance two kind of connected goals. One goal is to create research that will translate into useful knowledge for the society at some point. The other goal is to simultaneously maintain this curiosity that drives us. We need to avoid burnout, and to do this, we need to explore questions that might not be immediately useful, but are interesting, possibly conducive to huge breakthroughs somewhere down the line, maybe many, many years from now. But then in practice, it's really hard to justify playing with some absolutely cryptic idea that is of no immediate interest to anyone but us for, say, 10 or 20 years, while being funded by public money. And I think this tension is close to the heart of many scientists who have kept their natural curiosity, right? So how do we do that? We need to make sure that we set aside time to explore new things. We need to make sure that we're not just kind of mindlessly following the latest trends that are being pushed in within our community for the sake of landing a citable paper or, a press release, but that we're also contributing to the creation of new horizons or bringing ideas from other fields. That's a creative process that cannot be really automated. On top of that, we need to think about the way we engage with the public, whether these are guest appearances in popular science outlets, having our own YouTube channels and blogs, or maybe TikTok or Instagram pages. All of this will be needed for the future generations to be brought up in appreciation of science, feeling that science is something worthwhile. So, power to the influencer ones among us. If you have it in you, absolutely grab that smartphone and make that story, that reel, that TikTok, that content. If not, you can always be like me. I've always been terrified of talking to the public, but I dragged myself kicking and screaming into what I'm doing now, and it's a bit less scary each time around. But you don't need to be born for that for sure. Then we might expand that to think about how we can also have an impact in the real world through policymaking. So bringing up the story from Janusz, can we reach out to a political body to offer, or maybe we're asked to offer our knowledge, our expertise, our skills in interpreting the evidence for people who want to draft new policies. That will certainly take getting out of one's comfort zone, but it can also be a very impactful and rewarding contribution to the world of science and politics. And if, say, our original goal was to change society for the better, as I imagine it was for many of the listeners, so engaging in such activities can fit into our value systems, right? I mean, it is very easy to feel that we have no time for all these outreach activities and engagements and so on. It is true, we are all overloaded with work, but in the long term, if we solely focus on the technical aspects and purely scientific questions, we risk exactly this feeling of burnout. I mean, asking ourselves, okay, I've studied the most technical details of the most specialized theory out there and done administration, documentation, and so on. But in the end, what would the passionate teenager me think of that? The one who wanted to unlock, the mysteries of the world and maybe help people and maybe bring excitement about science to the public. That's my reminder that we should ask ourselves these questions at least once in a while. And that kind of bleeds into the other topic that was explored by, among others, by Saima, by Michele, and by Ariane, of our focus on therapies and drug design. So we've said many times, we are now in this world where increasingly, for computational people, we can start to think of, not just discovering mechanisms and describing what is happening on a molecular level, but also thinking of how we can go in and modify something, how we can play or tinker with this mechanism, how we can use something that biology devised to solve a problem that either biology or civilization created. And so not only we have more validated molecular targets, but we also start to discover what causes diseases on a deep level, right? We start to understand the Alzheimer's, we're starting to have mechanistic understanding of autoimmune disease. There was recently a paper about the whole pathway involved in inflammatory bowel disease, from a genetic variant of an enhancer all the way to gene products regulating the production of inflammatory pathways. There's going to be new pathways, new cues about how ALS, lateral sclerosis, or MS, multiple sclerosis, is brought about as well. It seems that almost every month there is a new discovery of a molecular pathway that contributes to a major disease. So this opens up a lot of space for us computational scientists thinking about how to address those diseases, right? We're accumulating more subtle explanations of failure modes of biology, but also failure modes of therapy. So we understand molecular assemblies, molecular barriers, metabolism better. As we talked with Saima, for example, we know what bacteria do to prevent antibiotics from reaching their targets. We get a better view, that was a point in the conversation with Paulo, of heterogeneous lipid membranes or cellular compartments that affect drug uptake and delivery. Ariane talked about how we can think of molecular crowding to avoid off-target effects and rethink drug efficacy. And so also with the proliferation of data, of databases, we can increasingly start to discover connections between different processes, and I think that we require a different approach to teaching and self-teaching as well. Everyone needs to know that you can now go to UniProt and find 30 different aspects of a protein's function, from mutational data to post-translational modifications to structural complexes with other proteins, or putative interaction graphs. With these and a bit of imagination, you can go to AlphaFold to start predicting complex geometries and see if that matches some coevolutionary patterns or loss of function mutations. And we can start churning out hypotheses for downstream experimental validation, which also means we need to learn modes of experimental validation. That's all complicated, that's all a lot of work, but that's what will transform the field in the next years, I believe. And of course, there's still a shortage of data to train our predictive models on, and that's a major issue. So we would like to solve many things with AI, with those automatic molecular design or network prediction systems, whatever. But the major problem that those systems face is, it turns out, lack of high quality data, whether it's for generative models or regressors or classifiers or you name it. So in medicinal chemistry, for example, the question of generating molecules that are chemically meaningful and stable is kind of solved. Not perfectly, but to a large extent. But to know what molecules do and how they behave in these complex environments, how they bind to, off-target sites, how they get metabolized or absorbed, and so on, this question will still rely on new sources of data. So here we have this dual, let's say, predicament of both having an enormous power that we have to learn to use and deal with that we didn't have before. But we also need to work on producing better data or extracting more meaningful information from the data that we have to help us get there. And that's going to take a lot of, again, imagination and trial and error. The next question that showed up a lot was that of fostering the technical and scientific skills within the community. That's something we talked about with Justin and Daniel. And something that comes up a lot is this dichotomy between, on the one hand, simplicity that can kind of drive up usability. That was also brought up by Paulo, by the way. That you can drive up usability through simplicity of the tool, because people will tend to use your software more if it's really, really easy to adopt. But then on the other hand, there are many decisions that have to be made that are tailored to a specific research question that we see advising on online forums. So this is the depth of the knowledge of the user, knowing the theory behind the tool. And it's not really immediately obvious how to balance those two, right? So the knowledge of the user and the usability or the simplicity of the tool. So in other words, how to make things easy to use, but not to a point where an average user is left blind to important choices or assumptions or really cannot interpret the output of the model. And that's why we cannot always solve someone's technical problem just by giving them this case-by-case advice. That's why we need to think of foundational training, I believe. So that's where things like textbooks or lectures come in. And so as both, I think Justin and Daniel were pointing out, these two modes of interaction need to reinforce each other. It's not really obvious how to communicate the complexities of our field to people who are just, undergrad students or first-time users of certain software. But we need to care about conveying the key physical foundations. So whether it is the trajectory or free energy centric vision, of pure statistical mechanics, or it's Markovian dynamics, all those things, it would probably be beneficial to have a core curriculum for molecular biophysicists. And I'm sure pieces of this exist somewhere, but maybe we should make a community-wide effort to emphasize what people need to learn in order to start working in computational biology. Because it will be a lot of different angles, right? You can have a perfect understanding of the biology, cell biology, molecular biology, and so on. What is DNA? What is RNA? But not know how those things translate into models and physics and so on. That's one failure mode. Another one is that maybe you're a computer scientist and you know that the models are there and the models do great things. Your harmonic approximation from a non-harmonic or non-linear or whatever. But you don't really know why terminal residues are special or things like protonation states, because these are some things that, chemists care about. So perhaps could we please have this central resource for the understanding of computational biophysics from a biology standpoint, from a chemistry standpoint, physics, math, programming, tools, and so on. Of course, the tools, evolve every month now, but the foundations, the basics are going to be the same for decades to come, I believe. And so it's never going to be a single book or like a single lecture that someone will go through and that's it. But I wonder if there is a standard set of resources out there that, let's say, if someone goes through them within a year or two, they will be at least able to recognize most problems or issues within the field. I think it would be amazing to work to compile such a curriculum and, tell the young people, look, here are the basics. We know you're lost. We know you're just trying to figure out what this thing is about. But before you move into advanced enhanced sampling with AI or, a new docking method, make sure you know what the field has been up to in the last 5 decades, about the foundations we have. You don't need to reinvent the wheel. Also make sure that when you do things, what's the goal of what you're doing, right? So as Justin pointed out, I believe there is this problem where people outside of the field, PIs outside of the field, think that they can tell their student, you just go do a tutorial, run a simulation, interpret the results, and have a section in your manuscript. It will be okay. It's just molecular modeling. And we need to be aware that while the technological part can be automated, the interpretation part, and that includes preparation of the setup, almost never can be automated. So you can have a perfectly valid simulation on a technical level. We can have all the technical checklists and quality filters and so on. If we don't train people to interpret the setup and the results of simulations on a statistical level or on a physical level or on a biochemical level, they will never extract valid conclusions from a perfectly well-run simulation. So the whole point is this, I think. Even if we make things automatable, it just doesn't mean that the science will be automated. And that's a major concern to me. And that's why we need more real collaboration. That's why we should definitely try to do interdisciplinary science. But the way to do interdisciplinary science, and this is not to say it's not being done like this, it's just to emphasize this is the right way, is not for every individual to do everything, but rather for people to engage in those productive discussions and rely on each other's expertise in solving those big questions. So that, when you need to do this particular thing, you can do it yourself with the help of a friend who knows what you're doing and will give you warnings about all the potential problems you might come across or what is actually doable, what is 20 years from now. And then to wrap up the last interesting topic, we have the question of setting our goals in life. So Saima alluded to this question of happiness as a point in life where we can follow things that are meaningful to us. So, we give things a meaning, we have agency, we get joy from engaging with the scientific questions, and we also have the tools to deal with different aspects of life, whether it's scientific or private. So this is a very holistic question in the sense that we need to have a sense of where we want to go. We need to have a sense of professional proficiency or success that gives us an actual power to do things. Because we cannot really follow our values if we don't have a say about what we study or what we work on in our professional lives. And then we need to have a way to deal with all the typical things that happen to people, whether it's health or family matters or rejections in professional life or collapsing life plans or handling professional and non-professional relationships. This is a big conversation, again, everyone has to have internally to figure out how life in the sciences allows you to reach a deeper sense of happiness, right? Not just this simple state of being content with yourself in the moment, but something that is in agreement with our deeper values, giving us a space to grow and resilience. And this perspective that we grow together with the people who are growing around us, I think it can help to think in these terms because we scientists are increasingly aware of our interdependency to come up with, say, the next discovery. At the same time, many people are driven to academia more by vocation and less by financial prospects. So we can use the fact that people are looking forward to growth and arrange a growth and kindness-centric environment. Again, having this conversation with yourself and people around you might really benefit one's clarity and one's path towards this fulfillment. And this seems to be another multi-scale problem in the sense that we can find meaning on so many levels. You can find meaning in your immediate professional circle, in your lab, or the interactions with people you mentor or with your mentor. You can find meaning in providing resources for the community, writing perspectives, books, educational materials, running podcasts, you name it. Perhaps, as we discussed with Vlad, is the feeling that you're bringing your expertise to your home country, contributing to a better future for the people you grew up among. Or you can find your happiness in being a public intellectual and trying to reach a broad audience, or neither of these. Maybe you find the point you really care about somewhere else. But the point would be to avoid escaping the discussion and having it in such a way that brings clarity into your lives, sometimes stepping back and reflecting on those questions. Even though we should embrace serendipity and kind of try to extract positive outcomes out of everything life throws at us. Okay, I'm ending on a somewhat philosophical note, but that's among the explicit goals of this podcast. I'm happy some of you take the opportunity to reach out to me to give your feedback. These are still early days of the podcast, so I take any suggestions fairly seriously. I'm also feeling more relaxed in my role as a host, so I hope this eventually translates into simply better conversations. It's been an amazing experience so far, and as always, I'm grateful to my guests for the time and thoughts they put into the recordings and to the audience for curiosity. I'll talk to you soon in Season 3. Thank you for listening. See you in the next episode of Face Space Invaders.